All right. B2, find two more points that lie on this line. Explain your method. Okay, so there's a lot of different ways we could do this. I think it might work to actually have a table of values to show this process. So if I do this again, I'm gonna have here like an X and a Y, kind of the same table we were doing before. And I know that I'm gonna have start off with, maybe I have like my -2 and 10, but maybe I need to go in and find out a couple others. So -1, 0, 1, 2, and 3. And I know this one's gonna be 5 there. So these 2 points we've got to work through. Now if you need to come back and take a look at this slope, remember this process, how we saw this -5, or 5 over -5, it's the same thing as actually having a 1 over -1. So remember the change of the y was gonna be -1, -1, -1, -1. Let's see if that actually holds true. So if I put that in, so if I have here 10 minus 1, that means this would be a 9. Minus 1 would be 8. Minus 1 would be 7. Minus 1 would be 6. Hey, look at that. That actually fits. Shows that process of that change. And then here's the change of the x, or the change of the other one would be +1, +1, +1, +1, +1 in that process. So you can see how that would work. Okay? So 2 other points we could place would be something like -1 and 9, or 0 and 8, or we could have 1 and 7, and 2 and 6. Those are all the points we could have had in that case. B3. Unmai observed that any 2 points on a line can be used to find the slope. How is Unmai's observation related to the idea of linearity? That's kind of a weird word. Well, let's test this. Could we actually go back to all these points here and see, could we plug any of these other points in there and see if we get the exact same slope? So let's try that. Let's see if I try these 2 points. Let's try this time. Let's try 0 and 8 and 2 and 6. So I'm trying this point and this point here. So this will be my point 1. This will be point 2. Remember that we're going to have, this is going to be x and y and x and y. So I'll plug all this work in here. So my slope is equal to, so if you recall from up here, I have y2. So I've got a 6 minus y1, which is going to be an 8, over x2, which is 2, minus x1, which is going to be 0. So if I do that, I'm going to have 6 minus 8, which is going to be a -2. And 2 minus 0 is going to give me a 2. And that simplifies again to a -1. So yeah, this concept of linearity, which is a really weird word, means, yeah, any points on that line can be used to find the slope. All right, part C. John noticed that for lines represented by equations of the form y equals mx, the point 0, 0, and 1m are on the line. Is he correct? Well, let's explain that. All right, so if I have a C, and they're giving us this idea of y equals mx. So let's just pick a number and sort that out. Let's just see. So what if I said that, let's try that the slope is equal to 3, like we had earlier on. So if I put that in here, I'd actually have a y equals 3x. If I put 0 in here, so I have x and y, and I found out that I have x is 0, and I have my x is 1. Those 2 values I just spoke of in this case. If I put 0 in here, 3 times 0 is going to be 0. If I put 1 in here, I'd have 3 times 1 is going to be 3. So yeah, that actually is true. Anytime we don't have a y-intercept or +0 or nothing there, that's automatically going to have the ordered pair to be 0, 0, and 1 in that number. So it's always going to be that case. Plus, this would end up representing a proportional relationship. All right, C2. What's the slope of a horizontal line? Let's start there. So in this case, I actually made a little bit of a graph in my, my notes here. Let's look at it as a series of points that we can find. So if I have some ordered pairs, so let's see if I've got this guy, and this guy, and this guy, and this guy, and this guy. So those ordered pairs would actually be, in this case, I'll write that down here. So x and y, I'd have 0, 3, 0, 3, then 1, 3, and then 2, 3, and 3, 3, and then 4, 3. So let's just look at that pattern here. Remember how that process works. It's that change of the y over the change of x. So I go 3, 3, 3, 3. That changes a plus 0, plus 0, plus 0, plus 0, right? So it's going to be 0 over. I've got 0, 1, 2, 3. So it's going to be plus 1 there. So I have a 0, 1. So 0 divided by 1 is going to be 0. So in this case, a horizontal line, the slope equals 0. All right, so now we have a vertical line here. I drew the same one on that same setup there. So you can see that I had some more points here. So let's start here. I've got 3, 0. I've got 3, 1. I've got 3, 2. And 3, 3. All right, so let's take that same exact test that we were looking for. So the change of the y over the change of x. What's happening with my y? I've got 0, 1, 2, 3. That's a plus 1, plus 1, plus 1 equals 1. 0, I've got a 3, 3, 3, 3. That's the 0. So in this case, 1 divided by 0. Now this is kind of a weird thing. You might remember this part here. We try to divide things by 0. But if I show something on the calculator, watch this. If I do 1 divided by 0, look what happens. I get an error. That means in this case, like when it comes to slope, a measurement of a steepness of a line, we would get this 1 over 0, or what we call this is going to be an undefined slope. And if you might remember that if you watched the slope dude video as well. All right, D1. Compare your methods for finding the slope of a line from a graph, a table, and an equation. Well, what we noticed that was probably the easiest way to go when it came to the graph is writing out the ordered pairs that we noticed in this case. That's one possible method that you could see, that if we wrote down those ordered pairs, you can process that change. But something that we didn't talk about as much, so I think we did specifically in the class, the Google Meet, is that there's that change of -3 over 1. So look, if I'm right here, I can go down 3 over 1, down 3 over 1, down 3 over 1. There's those same stair steps that we saw. That's the same process when I have a positive 3 over 1, I can do up 3 over 1, up 3 over 1, in that process there. When it comes to the table, same process, looking for that change, the change of the y over the change of x. That really helps us to understand the slope in that case. When it comes looking at our equations, very, very straightforward. Whatever number is with the x, that's going to be our coefficient, or going to be our slope. And whatever the other number being added or subtracted is going to be the y-intercept. That's how we would find that process there. All right, D2. In previous investigations, you learned that linear relationships have a constant rate of change. As the independent variable changes by a constant amount, the dependent variable also changes by a constant amount. How is the constant rate of change of a linear relationship related to the slope of the line that represents the relationship? Well, basically, the relationship between that constant rate of change and the slope of a line, they're the same thing. They are identical, as we talked about in class. So remember, the scale factor, unit rate, constant proportionality, that constant rate of change, and now the slope, they're all the exact same thing. So all these equations, their structure will all look the same for linear functions. All right, guys, that's what we have for today. Let's take a look at the ACE work. Today, you're going to be working on numbers 2 through 15. All right. Number 2, find the horizontal distance and the vertical distance between the two labeled points. Okay, look at that. They give it to you already. So they're showing the staircase in that case. So then what's the slope? That's all you have for those. Look at number 3 through 6. Find the slope and y-intercept of these guys here. Same process as we did on those equations there. Number 7. 7 possible descriptions of lines are listed below. So you have all these 7 options. It's not multiple choice, but you have to go through A, B, C, D, and E and find all of these that would match up with that. 8 through 12, they want you to take the tables, represent linear relationships, give the slope and y-intercept of the graph of each relationship, then match each equation to the appropriate table. So basically, each of these equations go with each of these. So you're finding the slope and y-intercept and then matching them to that equation. And then 13 to 15, find Find the slope of a line represented by the equation here. So what's that slope? Make a table of values for the equation. How is the slope related to the entries? 14, find the slope of a line that represents this equation. Make a table of value of those. 15, in parts A and B, the equations represent linear relationships. Use the given information to find the value of B. So you're using this information to find out what goes there. This is a little bit of a tricky one, kind of a little bit of a challenge. So we can talk about that if you need. All right, that's what we have. All right, guys, hopefully that helps. We'll catch you at the next Google Meet, or you'll see my face in our math book in the next YouTube video. All right, guys, hang in there. We'll see you soon. Bye-bye.